Hello everyone. I'm Dr. Pragya Acharya from AIMS New Delhi, and I'm happy to join you as your mentor in this Nobel Ideathon. Today we are going to explore a fundamental question. Why does the immune system, which is meant to protect the body, sometimes attack its own self? This failure of peripheral immune tolerance results in autoimmune diseases, from type 1 diabetes to IBD and autoimmune liver disease. In the last decade, our understanding of peripheral tolerance has grown tremendously. We now know that it's not a single checkpoint, rather, it's a network of cells and pathways. Regulatory T cells that calm inflammation, co-inhibitory molecules like PD-1 that prevent overactivation, tolerogenic dendritic cells that present self-antigens safely, and immune metabolic circuits that regulate and influence T cell fate. And these insights have inspired many new ideas in medicine, for example, CAR-Tregs, tolerogenic vaccines, and metabolic modulators. But we are still far from a cure. And two major challenges remain. First, we can't predict the loss of tolerance early enough, and by the time autoimmune symptoms appear, the immune system may have been drifting for years. And second, most current therapies suppress immunity broadly. They reduce inflammation, but they also increase the risk of infection and long-term complications. What we really need are precise antigen-specific solutions. And that leads us to two high-impact research directions in autoimmunity, where young innovators like you can make a real difference. Number one, early warning systems for autoimmunity. Can we detect the earliest cracks in immune tolerance years before disease actually begins? Imagine integrating genetics, proteomics, metabolomics, T-cell receptor repertoire analysis, and microbiome profiles. Can you build an AI-driven risk score that predicts autoimmunity before symptoms actually appear? Such a tool would change screening, prevention, and early intervention in autoimmune diseases. Second, reprogramming immune cells towards tolerance once autoimmunity already exists. Instead of shutting down the entire immune system and suppressing it, what if we could redirect it and teach it to stop attacking specific tissues? Here you can think of incorporating tolerogenic nanoparticles that deliver self-antigen, organ-targeted regulatory T cells, and metabolic reprogramming to shift inflammatory cells into a tolerant state. This is the future of precision immunotherapy. Now, you can imagine to solve such a complex problem as autoimmunity, you will need to work in interdisciplinary teams, combining clinical insights, molecular understanding, computational approaches for data integration, and engineering tools to develop diagnostics or delivery platform. For this type of a problem, collaboration would be your superpower. Finally, I just want to add that in this Ideathon, we encourage futuristic research ideas and prototypes that are not limited by cost or infrastructure, as long as they remain scientifically grounded and reasonably realistic. While I have included some concepts that you can think about, you are free to go beyond this and include other cutting-edge approaches such as synthetic biology, new biosensor designs in your innovations. Think boldly, creatively, and beyond traditional boundaries. I'm genuinely excited to see what you create in this Ideathon, and I look forward to meeting all of you. Thanks.